Good day, Lena. My name is Dr. Olatayo. I'll be taking study section 6. From the previous one, we've learned something on random variable, test of hypothesis. In this section, there are some variables that cannot be recorded in figure. They are ascribed as attributes, that is, attributes of an object, either good or bad, fear, and what have we. Those information has a lot to say about an event, and it cannot be analyzed or tested based on the method of the normal random variable. Therefore, the analysis of categorical data is quite different from the way we can analyze random variable. Now, the categorical data are data that are categorized based on attributes. It could be good or bad, fear, support, not support, and what have we. But if you have this categorical data, what method is the best that can be used to test the hypothesis and yet get a good decision from our hypothesis tested? One of the major methods is what we call chi-square distribution. Now, chi-square distribution is a special significance test which is used in a very large number of cases to test the accordance between fact and theory, that is, between observed and expected values. And the statistic chi-square is denoted by what is right on the chi-square is equal to the sum of observed value minus expected value, all square divided by expected value. That is, the observed one and the expected one, the differences between them are to be tested, whether to know the expected, the observed one follow the expected observation. Now, from the example 6.1, we have the information below. Then we have to test at a 0.05 level of significance whether the discrepancies between the observed and expected frequencies can be attributed to chance. Now, before we move further to this test, the chi-square, as I've said, is one of the major methods used to test the level of significance in categorical data. And it is very important and useful. We have three main uses of chi-square. One, to test the discrepancies between observed and expected frequencies. Two, to test the goodness of fit of any information. And the third one is to determine association between two or more attributes. That is there any relationship between them? If there is no, what are the reasons why there is no, or there are relationship between or association between those attributes? Back to our example 6.1, we have to test at the 0.5% level of significance, which is 5%. And normally in statistics, from the previous test of hypothesis you've used, we are used to 5%. But in life science, where they deal with life, they make use of 1%, which is 0.1. But in the normal cases too, we make, but on general basis, we make use of 5% level of significance. Now, the hypothesis we have to test now is H1. The frequency can be attributed to chance. And H0, which is the alternative as discussed in section 5, is that the frequencies cannot be attributed to chances, since the expected frequency is 250 and we have the probability of is 0.1. That means to get the expected frequency, we are going to multiply 250. These are the total numbers of the observed frequencies multiplied by the probability that resulted into those events, which is 0.1. And when we multiply 250 with 0.1, we get 25. Therefore, our expected frequency now will be 25 all through, since the same probability produces the observed frequency. We have the same probability 0.1 here, and therefore the expected frequency too will be 25 all through. Back to our formula. Now we are going to fit the observed value and the expected value into the formula of the chi-square. Therefore, the first one, observed frequency, is 22. 22 will be subtracted. We will subtract 25 from 22, divided by 25 all square, followed by the second to the last data, which is 26 minus 25 all square divided by 25. So the chi-square calculated is 140 all over 25, because the denominations are the same, and the answer is 5.60. Now, before we can know whether the frequencies can be attributed to chance or not, we have to compare the calculated value of chi-square with the tabulated value of chi-square. Now, from the question given, we were given that this must be tested at 0.05 level of significance, that is 95%, and the information given is from 0 to 9. This will be n minus 1, that is 10 minus 1, then it will give us 9. That is, from this information, we have 10 altogether. The normal formula is supposed to be 95% to n minus 1 or r minus 1. So it will be 10 minus 1, which is 9. Now we are going to go to the chi-square table, which I have a sample with me here. Now, is 0.05 subtracted from 1 will give us 0.95. And under is 0.95 here, which is at the top, we are going to check 9, and we have 16.9. This table has approximated this value, but in some other table, you can see some figures in front. And that is why you can see from your answers, the tabulated one here, we have 16.919. But here it has been approximated because from here it will be 0. And therefore we have 16.9 as the table value. Now we are going to compare the calculated chi-square value with the table value. And therefore, since chi-square calculated is less than chi-square tabulated, we accept the hypothesis that and conclude that the frequencies can be attributed to chances. If the decision is that if chi-square calculated is greater than chi-square tabulated, we reject the hypothesis. And since the chi-square calculated is less than the chi-square tabulated, we accept the hypothesis in this case, and we will conclude that the frequencies can be attributed to chance. The example 6.3 also says 900 men and 700 women were interviewed by an independent public opinion poll agency on their attitudes towards family planning. Below is the result of the interview. The respondents, we have men, we have women. We have in favor, we have opposed, and we have neutral. 3 basic categorical informations are derived from the interview. Now, under the in favor, 355 men, opposed 400 men, neutral 145 men, women in favor 365, opposed 240, and neutral 95. Now, does this data indicate a significant sex difference in the attitude towards family planning? Test at 0.01 level of significance. Now, the hypothesis, according to the question stated here, is that H naught there is no sex difference, and H1 there is sex difference, the expected frequency table is calculated below. Now what we do is that we come to the table given. We will do the additions of the table, vertical and horizontal. And here we have 900 and 700. Now here we have 720 and 640. Now to compute the expected value here, we are going to multiply the total value here with the total value and divided by the total number of the figures altogether, which is 1,600. So 900 multiplied by 720 divided by 1,600. The same way here, 640 multiplied by 900 divided by 1,600. And here we have 405, we have 360, and here we have 135. Then for the women, we have 315, we have 280, and we have 105. Now, having obtained the expected value, now we come to a chi-square table. Chi-square table properly, we have observed from the question given. So we have 355, 400, 145, 365, 240, 95. Then we now go to the computed expected value here. We pick from the 355, we have 405, we have 360, 135, 315, 280, 105. Now we are going to subtract the expected value from the observed value. Therefore, 405 from 355, now we have minus 15. Now 360 from 400, we have 40. 135 from 145, we have 10. 315 from 365, we have 50. 280 from 240, we have minus 40. 105 from 95, we have a minus 10. Now we are going to go to the second row, that is observed minus expected, all square. When we've subtracted it here, we are going to square all the figures here now. 50 square will be 2,500, 40 square will be 1,600, 10 square will be 100, and 50 square will be 2,500, minus 40 will be 1,600, and minus 10 will be 100. Now we are going to divide this value with the expected value, which is this figure now divided by 1,600, and we have all this figure for the first, for the second, for the third, for the fourth, and we add everything together. We have 25.961, which is chi-square calculated. The chi-square calculated now is 25.961. The degree of freedom, since we have 2 by 3, is going to be 2 minus 1 into 3 minus 1. So the degree of freedom will be 2. Therefore, chi-square will be 0.1 with 2 degree of freedom. So we go to our chi-square table to derive the value of the chi-square. Now we have 0.01. Subtracted from 1, we have 0.99. Under 0.99, we have degree of freedom 2. And we have 9.21, which is the table value for the chi-square of the degree of freedom. Therefore, we have chi-square calculated to be 25.961 and chi-square tabulated to be 9.21. And the decision is that we reject the hypothesis if calculated is greater than tabulated. And here now, since chi-square calculated is greater than chi-square tabulated, we reject H0 and conclude that there is sex difference towards family planning. That means there are difference few between men and women. Now we can see that the chi-square, having categorized the figures based on gender, we can see the difference and discrepancy between the belief towards the family planning of men and women. So in conclusion, the analysis of categorical data helps to understand the attributes that an information or investigation involve, rather than the random variables of figures. When we have an attribute that is attributed to an investigation, chi-square is in best position to test the hypothesis of that observation. Thank you. In the next class, we'll continue with the regression and correlation analysis. Thank you.